What's up, fam? It's your boy Kit again, and we're gonna solve the 2012 AP Calculus question 2. And so A is telling us to find the area of R. So what we're gonna need to do is, well, there's two ways we can find the area. We can find it by integrating it in terms of x and integrating it in terms of y. I'm going to do both for you guys, but we're going to start with, so here's A, part 1. I'm going to start with integrating it in terms of x. So in order to do that, we're going to set up our integral and find it from 1 to the intersection of our two lines that this area is being bounded by. So let's just call it A for all intents and purposes. And how we're going to find A is by finding the intersection. So we're going to set natural log of x equal to 5 minus x. And after you do the math, it's going to end up, x is going to end up equaling 3.69344. So yeah, we're gonna find the area under the curve between 1 to A, which is underneath the line natural log of x. And then again, this is in terms of x, so it's dx. And then we're gonna, so that finds this area, but we also have to find this area. So we're gonna add it to the integral from A to 5 of 5 minus x dx. Ends up equaling 2.986 about. And so there you have it. That's the first way we can attack this problem. Alright, the second way we can attack this problem is essentially by, well, it's by putting it in terms of y, which is essentially, what I like to do is I like to flip the graph. Here, let me do it for you guys. And then pretend like it's in terms of x. So now we're finding the integral from 0 to wherever they intersect again. So the way I found where they intersect in terms of the y value is just by plugging our x value of where they intersect, which is that, and then I plugged it into the equation y equals 5 minus x, which is one of our lines. You could also plug it into the y equals natural log of x, but 5 minus x seems a little bit easier to me. And then, so it would be y equals 5 minus 3.69344. Again, that value, and it comes out to equal 1.30656. So then, and then we're going to say for all intents and purposes that equals B. And then, so if you want to integrate it in terms of y, I think this is the harder way personally, but it's always an option. We would just find it from 0 to B, which is this line. It's B. So from 0 to B of 5 minus y minus e to the y. So 5 minus y is our first equation, y equals 5 minus x, and we're just putting it in terms of, we're just setting x equal to the other stuff, so it would fit in terms of y, because this is dy. So it'd be x is equal to 5 minus y. And then our natural log of x equation, y equals natural log of x. We're just applying e to both sides, so then it would be e to the y is equal to is equal to x. Yeah. So why we're making it 5 minus y, subtracting e to the y from 5 minus y, it's actually kind of like this. That'll help explain. So we're finding the area under 5 minus y, which is this, but that's this whole thing. And then we're subtracting the area of e to the y, which was this thing, which would just give us the area of R. And after plugging this into the calculator, we get the same answer, which is 2.986. And that's how to solve A. Alright, so for part B, it tells us that region R is the base of a solid. And for the solid, each cross-section perpendicular to the x-axis is a square. Write, but do not evaluate, an expression involving one or more integrals that gives the volume of the solid. So basically what we're doing here is looking at region R, and essentially they're telling us that it's made up of an infinite amount of squares coming up this way, coming out of it, and we're supposed to find the volume of that new shape. So imagine each of these to be kind of the top of a square, and we're looking down on it. So as we know, the area of a square, the area is just equal to a side squared. And a lot of the times you'll also get, it could ask us to find, it could tell us that the cross section is some other shape, like an equilateral triangle or something. And you can find the areas to all those different cross sections in the chapter 6 notes. But squares are usually the easiest ones to deal with, and that equation is a area is equal to the side squared. And then to find the volume of that, we just have to integrate the side squared. So let's do that. So our volume would equal the integral from 1, which is here, to A, which is, if you'll remember from part A of question 2, A is the x value where our two lines intersect. So 1 to A, and that value equaled, I think it was 3.69344. Yeah, that's correct. So we're evaluating from 1 to A of, this is the natural log of x line, of natural log of x squared dx, of course, it's in terms of x. And then, again, that's finding the volume, in our case, of this much of the region. But then now we have to find this much of the region, the remaining part of the region. So then that would be from A to, let's see, 1, 2, 3, 4, 5, A to 5 of, this line is 5 minus x, so 5 minus x squared dx. Squared because these are acting as a side of our cross section, which is a square. So that's our volume, and let's see, we just have to write it, we don't have to evaluate it. So this would be our final answer. Pretty simple. Alright, so for our last part, part C, it tells us that the horizontal line y equals k divides region R into two regions of equal area. And we have to write, but do not solve, an equation involving one or more integrals whose solution gives the value of k. So essentially what this is telling us is that there's some horizontal line, oops, sorry, I moved the paper. Yeah, that's fine. Some horizontal line at some value k, let's say it's right here, that looks about right, that divides our region R into two equal, that's a little bit off, obviously you can see this is a little bit bigger, but let's say that's k, and it divides our region R into two equal equal parts. And we're supposed to find the value of k. And how do we do that? Well, we can turn our graph 90 degrees, or 270 degrees, I guess. And then solve this thing in terms of y. So we're trying to solve from 0 to k. And because we already know the answer to this problem, it's just the answer we found in part A divided by 2, which is going to be 2.986 divided by 2. So because we already know the answer to that, we can just kind of set it up as an equation. So it's going to be the integral of 0 to k of 5 minus y, which is again this line in terms of y, subtracted from e to the y, which again is this line in terms of y. It's very similar to part A. And then we're just going to set this equal to 2.986 times 1/2, because that's what our answer is going to be, because they're exactly equal. The two regions are supposed to be exactly equal to each other, and the whole region is equal to 2.986. And that is our answer, because it's just asking us to write an equation and not solve it. Alright, if you guys are looking for even more help, these are two great websites that offer a lot of practice problems and great solutions to them. So I hope this video helped you guys, and I'll see you later.